Empirical formula is the empirical formula of a compound is the simplest possible formula given to the atom in a molecule of a compound. I want to repeat again. I said the empirical formula of a compound is the simplest possible formula given to the atoms in a molecule of a compound. It shows the simplest mole ratio of the atoms in each element in the molecule of the compound. That is, it gives us the simplest ratio, the ratio of each of the elements we have there, or the atom of the elements there. So, why the molecular formula? Molecular formula is the formula expressing the correct ratio by mass of elements present in a compound. We are going to be looking at some calculation that will help us to really understand how to apply this in this our class today. So we are going to start by solving question that has to do with the empirical formula. From there, we'll do the rest of them. Just hold on for a moment. Now, the question said, the first question said the empirical formula of a hydrocarbon containing 0.12 mole of carbon and 0.36 mole of hydrogen is, option A is CH subscript 2, option B is CH subscript 3, option C is C subscript 2, H subscript 2, and D option is C subscript 2 and H subscript 4. So the second question there is, what is the molecular formula of a compound whose empirical formula is C H subscript 2 O, and the molecular formula is 180. So let's do the work. Here we have hydrocarbon, which means hydrogen and oxygen is present. So what we do here is the number of moles of carbon there is, while that of hydrogen is. So now in order to get the simplest mole ratio, we're going to divide by the smallest. This tends to be the smallest. 0.12 tends to be smallest. So then 0.12 divided by 0.12, we have, it will give us 1. While 0.36 divided by 0.12 will then give us 3. So since we know the compound contains C and H, that is carbon and hydrogen, it means that carbon is here is 1 and hydrogen is what? 3. So the empirical formula is this, meaning that the correct option is this that we have here, that is B, where we have C H subscript 3. Now let's quickly go to the second question. The second question said that what is the empirical formula? Now we know the compound is this. This is the compound, empirical formula of the compound, and the molecular formula is molecular formula M. Let me say MF is equal to what? 1, or molecular mass. That should be molecular mass. The molecular mass should be molecular mass. This is molecular mass, not molecular formula. Molecular mass. The molecular mass mx M. Molecular mass is this. So so what we do here is, to get that thing done, we know that since the molecular formula is the actual ratio by mass of each of the compounds, it means that this one is the simplest. We can call this their actual ratio by mass now, you can call it N, where N stands for the actual ratio. So what we do here now, we know that in this compound, carbon is 12, hydrogen will be 1 times 2 plus 16, which is for this, and then all of them join together minus the N, which will give us the actual um, ratio by mass. Then all of them will give us 180. When we add up everything we have here, we'll have 30N equal to 180. So N will be equal to 180. That will give us to give us 6. So since we are looking for the molecular mass, it means that the molecular mass, which is the actual number of actual mole ratio by mass, will then be 6. Then 6 multiply 0 O, we have 6. 6 multiply 12, hey, 2 here. 2 here we have 12. 6 multiply C, we have 6. That means what we have will be carbon 12 and O will be what? So the molecular formula of the compound in question is C subscript 6, H subscript 12, O subscript 6. Thank you so much for being part of the class.